What's happening, dogs? Mr. Allen here. It's time to simplify with some trig. Now, one of the strategies I like to use when dealing with problems like this one is I write stuff in terms of sine and cosine. Usually a good starting point for a lot of different problems. So for secant, I'm going to have 1 over cosine of theta. And then for tangent, I'm going to have sine of theta over cosine of theta. And then we've got sine is just going to be sine of theta. We'll throw it over 1 here. So what's going to happen over in this dealio right here? Well, that's going to become sine squared theta. All right, so I'm going to have 1 over cosine theta minus sine squared theta over cosine. Now, I'm seeing common denominators here. Check this out. I'm going to have 1 minus sine squared theta over cosine theta. Now, in my numerator, we've got ourselves a part of the Pythagorean identities, right? So I've got sine squared theta plus cosine squared theta is equal to 1. And I can manipulate that by subtracting over that sine squared theta to the other side. And 1 minus sine squared theta is equal to cosine squared theta. All over cosine of theta. What can happen with these two cosines? We're going to simplify down to just cosine of theta. That is as simple as we can make it. Dang, that's pretty dope. It's a little scary when you don't have an equal to something. That's always nice when they're like, hey, it equals this. You got kind of a clue as to where you need to go. But generally the directions with these, they'll say simplify it down to one trig function, or like no fractions in the end, like no denominator, right? So you might have like a cosine squared or a cosecant squared theta, whatever. But in this case, just down to cosine theta. That's dope. That's awesome. Deuces.